Chapter 15, Oxidation and Reduction. Perhaps you have never heard of an oxidation and reduction reaction. However, this type of reaction has many important applications in everyday life. When you see tarnish on a silver spoon, rust on iron tools, or green patina on a copper roof, you're observing oxidation. 4 iron plus 3 oxygen yields 2 rust. When we turn the lights on in our automobiles, an oxidation reaction within the car battery provides the electricity. On a cold, wintry day, we might build a fire. As the fire burns, oxygen combines with carbon and hydrogen to produce carbon dioxide, water, and heat. When a fuel burns with oxygen, it's combustion, which we now describe as an oxidation-reduction reaction. When we eat foods with starches in them, the starches break down to give glucose, which is oxidized in our cells to give energy along with carbon dioxide and water. Every breath we take provides oxygen to carry out oxidation in our cells. The term reduction was originally used for reactions that removed oxygen from compounds. Metal oxides and ores are reduced to obtain the pure metal. For example, iron metal is obtained by reducing iron in iron ore with carbon. As more was learned about oxidation and reduction reactions, scientists found that oxidation and reduction do not always involve oxygen. Today, an oxidation-reduction reaction is any reaction that involves the transfer of electrons from one substance to another. (15.1) Oxidation-reduction reactions. In an oxidation-reduction reaction, abbreviated redox, electrons are transferred from one substance to another. If one substance loses electrons, another substance must gain electrons. Oxidation is defined as the loss of electrons. Reduction is defined as the gain of electrons. One way to remember these definitions is to use the following acronym. Oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. In the formation of ionic compounds, we have seen that metals lose electrons to become positive ions and nonmetals gain electrons to become negative ions. We can now look at the oxidation and reduction reactions that take place when calcium metal reacts with sulfur to produce ionic compound calcium sulfide. Calcium solid plus sulfur solid yields calcium sulfide solid. The element calcium in the reactants has a charge of 0, but in the calcium sulfide product, it's present as a calcium 2 plus ion. Because the charge is more positive, we know that the calcium ion lost 2 electrons, which means the calcium metal was oxidized in the reaction. At the same time, the element sulfur in the reaction has a charge of 0, but the calcium sulfide product, it's present as a sulfide ion. Because the charge is more negative, we know that the sulfur atom gained 2 electrons, which means that reduction reaction took place. Thus, the overall reaction for the formation of calcium sulfide involves an oxidation and a reduction reaction that occurs simultaneously. In every oxidation and reduction, the number of electrons must be equal to the number of lost must be equal to the number of electrons gained. Because each shows a loss or gain of 2 electrons, we can add them and write the overall equation of the formation of calcium sulfide. Calcium, a 0 oxidation number, yields calcium 2 plus 2 oxidation number plus 2 electrons. Sulfur, a 0 oxidation number plus 2 electrons yields sulfur minus 2 oxidation number. The overall equation without charges is written as calcium plus sulfur equals calcium sulfide. As we see in the next reaction between zinc and copper 2 sulfate, there's always an oxidation with every reduction. Zinc solid plus copper sulfate yields zinc sulfate plus copper. We can rewrite the equation to show the atoms and the ions. Zinc solid plus copper 2 ion plus sulfate ion yields zinc 2 plus ion plus sulfate ion plus copper metal. Figure 15.1. In this single replacement reaction, zinc is oxidized to zinc plus 2, and when it provides 2 electrons to reduce copper 2 to copper 0, or copper solid metal. In this reaction, zinc atoms lose 2 electrons to form zinc 2 plus ion. This increase in positive charge indicates that zinc was oxidized. At the same time, copper 2 plus cation gains 2 electrons to form copper metal. The decrease in charge indicates that copper was reduced. The sulfate ions are spectator ions, which means they're present in the reactants and the products and do not change.